So to begin our study of geometry, I want to look at points, lines, and planes. And these three things are known as undefined concepts. I'm just going to refuse to define them. And it turns out in mathematics you need to have certain things be undefined, otherwise you end up with circular definitions. That'd be definitions that use the thing that you're trying to define in the definition, which isn't very good. So we're just going to assume that we understand what points, lines, and planes are, and we're going to build from there all the different things that we're going to need in geometry. So to start with, let's look at a point. So here's a point, there's a point, there's a point. And if I want to talk about one of these points, it would be nice to have a name for that point. We'll call that point A, that point B, and that point C. And so you'll notice that points here, we're representing them as dots, but they actually do not have a size. So even though I have a tiny little dot representing a point, that's really just a way of getting at the concept of a point. In reality, there's no size to the point. It's just convenient to label it as a dot. And points represented by dots also need names, and we name them with capital letters, like I did here with A, B, and C. How about a line? So there's a line, and maybe we have a point A and a point B that are both on this line. And so to name this line, I can name it as AB with a double-sided arrow on top. And that indicates that this line keeps going forever and ever and ever in both directions. And the order doesn't really matter. I could also name it as BA. Those would be the same line. Or another alternative, I could use a lowercase letter L here to represent the line. So important things about lines. Lines are made up of an infinite number of points. So I have points A and B labeled on this line, but it turns out that there's an infinite number of points. I could have picked any other point on the line. Lines extend to infinity in opposite directions. And lines can be named in two ways. So we saw that you can pick any 2 points on the line and put a double arrow over them, like I did with the A and the B. And also, you might sometimes see points named with, you might see lines named with 3 points, like A, B, C, and then you would have a big double arrow over all 3. But more often than not, you'll see just 2 points used. And you could also just use a lowercase letter to name a line. What about planes? So here is a plane, and we'll call this plane R. And here's another plane which has 3 points, X, Y, and Z, shown here. And so I could name this as plane XYZ. Notice for a line, we needed a minimum of 2 points to name that line. For a plane, you need a minimum of 3 points. So planes have no thickness. So you can imagine a very, 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 very thin piece of paper. So thin that it actually has no thickness. That would be a plane. I know, it's a hard thing to visualize, but again, these are concepts that are undefined, but we're just going to try and assume you're familiar with them. Planes extend to infinity, so that piece of paper that you have, imagine it extending to infinity in all directions. And planes can be named in 2 ways. Use a capital letter like I did with plane R, or use 3 points that lie in the plane like I did with plane XYZ.